Hello, Algebra 2 people. Welcome to assignment 2 for week 2. We're going to talk about multiplying and dividing fractions. Yep, everyone's favorite, fractions. First, let's start off with a little bit of review from what we should already know so far, and that is how to multiply fractions. When you multiply fractions, you just multiply straight across. So, for example, if I was going to multiply 3/5 times 2/7, I just take 3 times 2 to get 6 on the top and 5 times 7 to get 35 in the bottom. And so I get 6/35. It's just that simple. That's how we multiply. Let's look at how to divide. When we divide fractions, we when I was young, we said invert and multiply, but I know those are tricky words for some people. So I think nowadays they use like keep it, change it, flip it, or copy dot flip, something like that. Either way, what it means is when we divide by a fraction, what we do is we take the first term, in this case 3/5, and then we change the division into multiplication of the inverse. And when we invert a fraction, we turn it upside down. So we're going to put the 7 on the top and the 2 on the bottom. So the problem changes from 3/5 divided by 2/7 into 3/5 times 7/2. We're going to keep the first term, change it to multiplication, and flip the second term. That's your copy dot flip idea. Keep it, change it, flip it, however you want to look at it. But now once we're into a multiplication problem, we're going to do the same thing as we did over here. We're just going to multiply the top numbers. 3 times 7 is 21, and 5 times 2 is 10. And so 3/5 divided by 7/2 is 21/10. That's our review for that. But what happens when we have things that are the same on the top and the bottom? Like we looked at last lesson, you might have factors that are the same on the top and bottom, and then you can cancel those out or divide the top and bottom by those numbers. So when I look at this, I notice that 9, right, has factors of 3 times 3, and there's a 3 on the bottom. So I could think of 9 not as 9, but think of it as 3 times 3, and then cancel out a 3 from the top with a 3 on the bottom, or divide 9 by 3 and get 3, and divide 3 by 3 and get 1. And 2 and 5 don't have anything in common. 3 and 5 don't have anything in common. So we've canceled out any common terms, and we can just go ahead and multiply it like we did before up here. We're going to multiply what's left on the top. In this case, we still have a 3 here, and we still have a 2 here. So 3 times 2 is 6. And on the bottom, you have 5 times 1. When I divided 3 by 3, I got 1. So I still have to take 5 times 1 and get 5. So when we multiply across, we get 6/5. Let's look at a division problem. We have 9/5 divided by 2/3. Can we cancel common terms out? Well, be careful because we haven't changed the problem to multiplication yet. We have to change to multiplication before we try to cross cancel. So we'll keep that first term as 9/5. We'll change it to multiplication, and we'll flip this one upside down. And now we have 9/5 times 3/2. Is there or are there any common factors on the top and the bottom that I can cancel out? And this time there's not. 5 doesn't have anything in common with 9 or 3. 2 doesn't have anything in common with 9 or 3. So I can't cross cancel here. I can't cancel like terms out in this case. 9 times 3, we just multiply across. 9 times 3 is 27, and 5 times 2 is 10. And so in this case, I get 27/10. Okay? Just like that. The reason I put that one in there was to let you know that you cannot cross-cancel before you start to multiply. You're going to have to try and multiply or set it up as a multiplication problem before you can cancel, right? Groovy. So what does this have to do with let's see if I can move this around. What does that have to do with algebra? Because, that's back in grade school. We were multiplying fractions in hopefully third and fourth grade. But we can do the same thing with our variables. So I thought maybe I'd show you just a reminder on how some of this works. If I'm dividing variables, like, okay, I have the same variable, but it's raised to different powers, then I just change that so it is the variable raised to the top number minus the second number. So for example, if I had x to the fourth over x to the third, it's the same thing as x raised to the 4. Why did I put 1 power there? Mr. Fokin is falling asleep at the wheel over here. 4 minus 3, because you're going to take 4 minus 3. You're taking n minus m. You're taking 4 minus 3. When you have a number raised to a power on the top and that same number raised to a different power on the bottom, it is just that number to the first exponent minus the second exponent, or the exponent of the numerator minus the exponent of the denominator. And so x to the fourth over x to the third becomes x to the 4 minus 3, which is x to the first. Now, some of us still feel comfortable writing x to the first. We don't have to. Mathematicians get pretty lazy, so we usually just write x, because x to the first is just x, right? Now, that's fraction, or that's what you do with fractions. But then I thought, you know what, probably better review just a little bit on what we do when we multiply numbers together with exponents. And so real quick, you remember that if I had some number raised to a power times that same number raised to a different power, it's equal to that number, and you add the exponents, right? So for example, if I had x to the fourth times x to the third, that would be x to the 4 plus 3, which is x to the 7th, since 4 plus 3 is 7, right? That was just a quick review on multiplying those, and hopefully we remember that. So let's apply our new knowledge to these fractions. Up here, I have x to the third over z and z squared over y. And so I can see that I have a z squared up here, and I have a z. And do you know what the exponent on that z is? On the bottom here? The exponent on that z is 1, right? So I do have a situation kind of like what I had up here. I have a number raised to a power on the top, and that same number raised to a different power on the bottom. So here we go. We could say, well, that's going to be z to the 2 minus 1 power, isn't it? Now, I can't cross-cancel anything here. There's no x's in the bottom that I can cancel. So in this case, I still have an x to the third, but now I have a z to the 2 minus 1 power, right? 2 minus 1 power. And that's everything on the top, right? But on the bottom, I still have a y. So don't get rid of him. He stays there. What is 2 minus 1? Yeah, it's 1. So if I really simplify this out, I'm going to go, that's x to the third times z over y, since z to the 2 minus 1 is just z to the first, and we don't have to write 1 when it's an exponent. Make sense? All right, moving on. We have over here x to the third over z. Now we're going to divide by z squared over xy over z squared, isn't it? Yeah. So what do we do with division problems? Copy, dot, flip, they said from elementary school. So hopefully we're going to keep that first term, x to the third over z, but now we're going to change the division into multiplication, and we're going to flip this one upside down to make it z squared over xy. All right. So do we have some of these things like this happening? Any of these things kind of happening over here? Yeah, I see some things like, for example, I have an x to the third up here, and then I have an x to the first over here. So if I think about it, that's like x to the 3 minus 1, because I can take this number minus the exponent there, x to the 3 minus 1, right? And then I have a z squared up here and a z down here, just like we did in the previous problem when we had a z squared up there and a z down there. We could do z to the 2 minus 1 power. We'll do the same thing here. We got z to the 2 minus 1 power. And then we had in the bottom, we still had a y that we haven't taken care of. And some people might go, wait, you got a z and an x down there too. Well, I know, but I did take care of those because that was z to the first and that was their z to the 2 minus 1. So I've already taken care of that here. And there's an x down here, but I did say x to the third minus 1, right? Because that 1 was on this x. So I did take care of my z that was down here and my x that was down here, but I still have my y. So I'm going to write that down there because it's still down there. Didn't go anywhere. Let's finish this up. What is x to the 3 minus 1? Yeah, it's x squared because 3 minus 1 is 2. And z to the 2 minus 1 is still going to be z. And on the bottom, I still got my y. So that becomes x squared z over y. Makes sense? Sure, it's all fun and games, and Mr. Fokin's doing it. It's when you get to the homework that it gets tough. One more thing we're going to look at before we do a couple sample problems on Manga High, and that is to say, what if you had numbers and variables together? Ooh, spooky. Not too bad. You're going to do the same thing. So just like we were doing, on these previous problems, when you're over here, you're going, oh, is there anything on the top that has common factors with something that's on the bottom? If so, you can cancel those out. Sure enough, when you look at this, I can see some common factors on the top and the bottom. For example, 4 on the top and 2 on the bottom, they both seem to have common factors of 2. If I were to take 4 and divide by 2, I'd get 2. If I were to take 2 and divide by 2, I'd get 1. So I can cancel out a 2 from those. And then notice there's a 9 on the top here and a 3 on the bottom here. So they have common factor of 3, they all said. Yes. Okay. So if I took 9 and divided by 3, I'd get 3. And if I took 3 and divided by 3, I'd get 1. Is that all I can do for cross canceling? Kind of. Let's see what we got going here. We're actually kind of canceling some variables as we go too, but let's write these just the way we did in the previous problems. Over here, I got a 2 and a 3 on the top. So you got to multiply because that says multiplication. 2 times 3 is 6. Now, there's an x squared up here, and there's an x to the third here. So I can write this as x to the 2 minus 3 to take care of those. And then I see that there's a y here, and there's another y there. I don't have any y's in the bottom, but there's a y there and a y there. And y times y is y squared. And then up here I see a z squared. And down here I have a z to the 4th. So yeah, we should probably write that as z to the 2 minus 4. Now, you always have to subtract the one that's in the denominator from the one that's in the numerator. So when you look at this, it's like 2 minus 3. And the one that's upstairs is the numerator. So I got to go 2 minus 4. Just in case you were wondering. Have we taken care of everything? Well, I took care of the z's. Yeah. I took care of the x's. Yeah. I got 1 times 1 on the bottom, so I could put that all over 1. But you know what? You can always put something over 1. We don't really have to write it that way. But let's see what we got going up here. We've got 6 x to the, what's 2 minus 3? -1, they all said in unison. Thank you very much for saying that. And then we got a y squared still, but then we have a z. What's 2 minus 4? -2, they all said again. Do you remember what you do with negative exponents? Let's review. X to the -1 is 1 over x. X to the -2 is equal to 1 over x squared. X to the -3 is equal to 1 over x to the third. X to the -4 is equal to 1 over x to the fourth. So what negative exponents really do is they say that's got to change positions. If it was on the top of a fraction, it's got to go to the bottom of a fraction. And if it was on the bottom of a fraction, it's going to go to the top of the fraction. We've talked about some of that stuff before, but these are negative exponents, and that just means that these numbers are going to have to go into the denominator. So I'm going to get a 6 on the top and a y squared on the top, but on the bottom, because x has a -1 exponent, it goes to the bottom. Since x to the -1 sends x to the bottom of a fraction. And then we look up here and we had z to the -2, so that z's got to go on the bottom. Boom. And now it's raised to the +2, since if I took x to the -2, it goes to the bottom and becomes an x to the +2, right? So negative exponents are going to swap places. If it was on the top of a fraction, it's got to go to the bottom of the fraction, and vice versa. If you had a negative exponent and you're looking at the bottom of the fraction, that would move upstairs to the top of the fraction. And that's how that goes. Let's do some problems on Manga High. Yeah, these ones. Uh-oh. My face is in the way. I hate it when my face gets in the way. All right. Play. Notice I'm starting on easy level. Let's play. I'm going to simplify 2 times 3 over 2 times 4, and see they've already kind of got these factored for us. Do you see a factor in the top and the factor in the bottom that might be able to cancel? I do. 2 and 2. That's going to leave us with a 3/4. Ta-da! Uh-oh. This x is being raised to a -2 power. What does that do? Why, that sends it to the bottom and makes the exponent positive. True. Do you see some things that I can cancel there? Yeah, let's cancel the 2's, and you got 1 over 4. We're on fire. We're up to medium. Write this as a single term. Well, we're going to have to take our 8 times our 2 to get 16. And we're going to have to take x squared times x to the 4th. And, of course, when you multiply, if the base is the same, you add those exponents. So that's going to be an x to the 6th. So we had 16 x to the 6th. Work out. Going to work out today. All right, work out. 2/5 divided by 1/6. You're going to have to invert and multiply this. That's going to be 2/5 times 6 over 1. Let me show you what I mean. You got to flip that over, right? So you have 2/5 divided by 1/6. You're going to have to keep it, change it, flip it idea. Right. Yeah, right. Which was going to be 12, because 2 times 6 is 12. 5 times 1 is 5. 12/5. So race back over here and go, must be 12/5. Simplify 4y times 9x. Well, what's 4 times 9? 36, they all said. So we're going to take 36 xy. 36 xy. So simplify 4x squared over 3 divided by 3 over x. What are we going to do with that one? Keep it, change it, flip it, they all said. We're going to invert and multiply. Let me show you what I mean. That's going to now be 4x squared over 3 times x over 3. So, because we had to keep it, change it, and flip it, right? Like, so we had 3 over x, that's going to become an x over 3. So, 4x squared times x is 4x to the, third, because 2 plus 1 is 3. And 3 times 3 is 9. Don't say 6, we're not adding. That's 4x to the third over 9. Boom, 4x to the third over 9. Do you see anything and any common factors on the top that we could cancel with anything on the bottom? Yeah, I think this 6 has a 3 in it, so I can divide by 3. So 6 divided by 3 is going to be a 2x to the third times 5x to the third, so that's going to give me 10x to the sixth. And I want you to look at how they're kind of writing these. And then, of course, 3 divided by 3 here is going to be 1. So you got 1 times 3. It's going to give us, it's going to be this one. But I want to show you real quick. Like, I would write it this way, 10x to the 6th over 3. But they're going to write it this way. They're going to go 10 thirds x to the 6th. And that's fine. Any number that's on the top of the fraction could be written separately. I mean, they really could have written it x to the 6th over 3 times 10. I mean, that would be the same as well. But typically, goofy mathematicians will write the variable off to the side so that they have what's called a coefficient in front of it. Some people like to do that. So 10 thirds would be your coefficient in this case. But it's the same thing as 10x to the 6th over 3. So let's pick that one. Boom. Simplify this. Are there any common factors between 60 and 12? Yeah, I think so. Grab my calculator real quick, but I think you can actually take 60 and divide by 12. You get 5. So 60 divided by 12 is going to give us 5 up here. We can say, that's 5. And then, I even have a pencil. I wonder if that works. Bingo. So that's going to be 5. Woo. So that's going to be 5. Instead of 60, because I divided it by 12. If I divide 12 by 12, I get 1, right? And notice that x to the 7th and x to the 4th is going to be x to the 7 minus 4. What's 7 minus 4? Yeah, so we're going to have an x to the 3rd. So think about that. You got 5 over 1 times x to the 3rd. That's just 5x to the 3rd. That one. Uh-oh, got to get my eraser. It's a different problem. We're on fire, by the way, in the extreme mode. What are we going to have to do with this one? Copy, dot, flip, or keep it, change it, flip it, invert and multiply. Invert and multiply, invert and multiply. So you're going to change this to multiplication and flip this term upside down, and then look for common factors. I think you got the picture. Should be able to work your way into extreme and gold medal land in no time at all. So I'll let you get started. Good luck to you. Have a good rest of your week, and hopefully we'll see you soon.